Hello students, in this session I am going to explain about the new topic of the BSc second semester is operational amplifiers. Operational amplifiers, they have mentioned the two names of that operational amplifiers is operational and amplifiers. Amplifiers you have studied already in your BSc first year and PUC also. Amplifier means it is increasing the signal strength, right? For example, if you are giving the input signals, it can increases the signal strength of the your signals. That is called it as an amplifier. Here they have mentioned the operational amplifier. This is the one kind of the ICs, integrated circuits, they have mentioned. Integrated circuits means the many of the transistors and the discrete passive or active components they have fabricated on a single chip. That is called it as a integrated circuits. In the previous videos I have explained about the integrated circuits, right? That fabrication methods, classifications, I have already explained about this one. In this session, I am going to explain about the operational amplifiers, or we can call it as an op-amp. The first, before explain this operational amplifier, the application is very important for that one. Applications of operational amplifier is they are using in a AC or a DC signals, right? We are using in the signal generators, biomedical instruments they are using, and also oscillators, active filters and comparators and regulators they are using the operational amplifiers. These are the applications of the operational amplifier. And how it has invented this process, how it has started first, right? The first, I have already in the previous video, I have explained about the generation of computers. First generator, what kind of things they have used, like a vacuum tubes. In second generators generation, they are using some transistors. Third generation, they are using some ICs, right? Here also some generations how it has started inventing about the operational amplifiers. First it was started on 1946, the pattern of the vacuum tubes. Using the vacuum tubes, the operational amplifier they have created with a huge number of discrete elements. And second generation it was invented on 1953. First commercial operational amplifier they have started, they have fabricated on that one. And next one is a 1961, it was a discrete integrated circuit. Discrete integrated circuit, this one is your like a PCB. They have the discrete elements like resistors, transistors and capacitors. They have fabricate, otherwise they have soldering on that PCB, right? Then is a monolithic op amp. Monolithic op amp operational amplifier. Monolithic, I have already explained about this fabrication method, like one transistor or a single monolithic, a single stone, right? Mono means one and uh, lithos. It is a Greek word they have taken from that one. It is used for that monolithic op amp operational amplifier. Monolithic operational amplifier, a single stone, a single transistor they have arranged in a single ICs. then they have to try that one. And next one is in 1967, the first summing operational amplifier. That name is a mu A741. They have given a name for this IC, that is called it as an operational amplifier. At present days, you are using that kind of ICs in a 8-pin IC integrated circuit. The generation you have studied, the first amplifiers in the 1965 monolithic op amp is like your MOSFET. Thus, you have already seen the FETs. That's the same thing they have fabricated. Like monolithic op amp is like that. That picture of that one. In 741 operational amplifier, 8 pin ICs. In your practicals also, most of the practicals are will come on this unit. 3 to 4 experiments are there on operational amplifiers. This is a big unit and very important for your examinations also, and this is a very important unit for your further in your next semester also, right? And what is the operational amplifier? We are going through the definition of the operational amplifiers. Like, the definition of the operational amplifiers of op amp is: operational amplifier is an integrated circuit that can be amplify the weak electric signal. An op amp has two input pins and one output pins. Is there some problem? It is there. It is a output output pin. Like, output pin, it is a basic role is to amplify and output the voltage difference between the two inputs. The meaning of this one is, right, the meaning of this is like two terminals are there. Like, one is a inverting and another one is a non-inverting terminal. Like, one output it is there. The how to depends on this output. Before going to study of that one, what is the inverting input and what is the non-inverting input, right? What is the inverting and what is the non-inverting? For example, I am going to draw this one is a signal. If your circuit is a inverting terminal, the phase will be shift 180 degree with the high voltage. It is a high voltage inverting terminal, that pin number is 2, and non-inverting terminal input. Non-inverting terminal means if you are giving the same signals with, you are giving the high gain, same signals will form without a distortion. You are getting the same signal, and but it is a same with the high gain you can get it, but you can the invert that one is not invert the signal. If you are giving the sine wave, you can get the cosine wave. Plus Vs and minus Vs are the power supplies. The DC as well as AC you can connect it. And one more terminal, if you are applying the voltage, to the inverting terminal, it is a inverting circuit. If you applying the input voltage to the non-inverting circuit, that is a non-inverting circuit, you can form that one, right? This is the uh, this is all things get happens like the same thing it is in the operational amplifier. This is a circuit for that one, like this is the output. Then come to the output. Output is a it is a difference between the inverting and non-inverting voltage, huh? with a gain, with a gain, right? That is called it as an output. Two inputs we are giving and the one output. It is the schematic diagram of the, this is a schematic diagram of the op amp. This is a schematic diagram of the op amp, right? Next is a pin configuration of the operational amplifier. This is a, I have already explained about this one, is a 8 pin ICs. 8 pin IC, it is a 8 pin IC. This is a circuit, this is a pin configuration. Pin 1 is a offset null. Pin 2 is a inverting input. Pin 3 is a non-inverting input. And pin 4 is a minus VE. Pin 5 is a offset null. And pin 6 is a output. Pin 7 is a plus V. Pin 8 is a not connected. Otherwise, we can call it as an NC. Have you observed in this pin configuration, right? 1 and the 5 are the offset null, right? Offset null means what? The difference between the inverting and the non-inverting terminal. The difference between the inverting and the non-inverting terminal, the output will be get it. In the output, many of the distortion occurs. This 1 and 5 pin configurations trying to avoid that. Means, for example, the if you are giving the inverting terminal 2 volt, non-inverting terminal 1 volt, the difference is 1, right? The one is giving the input here, the output, will you get it 1? No, some distortion it is there. If you are getting the 0.8 in the gain in the output, if these two are the 1 and the 5 are the output, will you get it in the at least 0.95? It is trying to do that one. That offset null is doing the this kind of work. Inverting, I have already explained about this one, is inverting input. If you are giving the sine wave, you can get it in the cosine. Non-inverting, there is no any signal changes in that one, you can get the same output. Minus V and the plus V. The minus V and the plus V are the power supplies. If the output is depends on these two, if the output is high, that voltage should be in the 5 to 18 volts. It is there. That voltage is around the 5 to 18 volts. And the output is high, the positive voltage it can take. If the output is low, the negative volt will be appear at the output. How it will depends? It depends on the inverting the input or non-inverting the input. It is depends. It is like a not connected. It is like a dummy. There is no any other connections in the 741 IC. Like, and next is most of the applications of the operational amplifier. Applications are the operational amplifier is a versatile device. Why we can call it as a versatile device? It can be used to amplify the DC as well as the AC input signals, right? It was generally designed for the performing the mathematical operations like addition, subtraction, division, multiplication, integration and differentiation. It can do this op amp or this is a IC, it can work. The modern day op amp can be used for a variety of applications such as AC DC signal amplification and active filters, oscillators and audio amplifier, signal generators. You have seen the signal generators while you are doing the CE amplifier experiment. You have used for the signal generators, that is a pure AC signals. You can get it in the pure AC signals in the output, right? They have used this method on that signal generator instrument. And biomedical instruments in the medical, many of the usages are there, this IC, right? uh, and most of the usages, we can see that operational amplifiers, right? And most advantage of the operational amplifiers are it is cost is very low. It cost at present it is just 8 rupees per IC. That cost 8 rupees per IC. 741 IC, NCA 741 IC's cost is around 8 rupees. That is very reliable. It can easy to fabricate. Hmm. The most of the users are there for the IC741. Next one is a block diagram of the. This is the block diagram of the IC operational amplifier, right? In this block diagram, I want to zoom this one. First one is the inverting terminal and the non-inverting terminal enters this first stage, that is called it as an input stage. They have mentioned differential amplifier, dual input and the balanced output they have mentioned. In this stage we can get the high gain of the amplifier, and that means it is a dual input and the balanced output. If you are giving the inverting and the non-inverting voltages, and you can get the high gain of the amplifier in this stage, and also establish the input resistance of the operational amplifiers. The intermediate stage, next stage we can call it as a intermediate stage. They have given, this is called it as an intermediate stage. The differential amplifiers dual input unbalanced output they have given. The differential amplifier which is driven by the output of the fifth stage. In the most amplifiers, the intermediate stage is a dual input unbalanced or single ended output, we can call it, because the direct coupling is used. The DC voltage at the output of the intermediate stage, as well as above ground potential. Therefore, generally the level of the transistor circuit is used. Right after the intermediate stage, the next stage is to shift the DC level at the output of the intermediate stage. It is the it is the it downwards to 0 volts with respect to the ground. The final stage is the usually the push-pull complementary amplifier output stage. The output stage increases the output voltage. It increases the output voltage swing and raises the current supplying capability of the op-amp. As well, designed operational amplifiers of the output stage also provides low output resistance. Means that the if you are giving the input here, the in the dual input and balanced output, the established the resistance. If you are providing the voltage, obviously the current will be there, or if the current will be there, the resistance will be there by the Ohm's law. V equals to I into R. If the voltage it is there, the current will be there, the resistance will be established in the input resistance, we can call it. In the intermediate stage, in this stage, the that will be creates, we can get the high gain in the after the input stage. You can get the high gain. You can get it in the high in the output, right? Which is driven by the output of the stage. In the stage of the unbalanced means single ended output. In the next stage is the intermediate stage, that is the unbalanced output they have mentioned, that is called as a single ended output, because the direct coupling is used, the DC. The output in the intermediate stage well above ground potential, that is the increasing the ground potential level. And then after the intermediate stage, to shift the DC level at the output of the next DC level bit, it is level shifting to the emitter follower. Emitter follower you have studied in a transistor in an emitter follower you have studied. The output of the intermediate stage downwards to 0 0 volts with respect to ground. The final stage, this output will be with the constant current source. It maintains the constant current source, because the sign, you can see that one, two inputs transfer to the intermediate stage, whatever input they have given, that the same output with the high gain, it transfers the differential and amplifiers, and then it comes to the intermediate stage. Then it increases the coupling usages and all those things. Then the one more it comes to ground, the level shifting stage. With respect to the ground, the final stage push pull, when it comes to emitter follower, the one is connected to ground, that connects to ground here, that connects to ground here. Then afterwards, the whatever output it is there, it maintains the constant voltage. It supplies to the output amplifying stage or a push pull amplifier stage. We can complementary symmetry, we can call it as. In this stage, increases the output voltage swing and raises the current supplying capability of the op amp. A well designed output stage also provides low output resistance. If the current is rising, current will be high. The obviously the resistance value will be very less. If the voltage it is increasing, what will happen? Voltage it is increasing, resistance and the current will be increasing. If the only the current is increasing, resistance will be decreasing with respect to increasing the voltage. The high voltage we can get it in the output stage of the operational amplifiers. You have studied in this session about the operational amplifiers, applications, and the established and the schematic diagrams, definitions, and the pin configurations and the block diagram of the IC. You have block diagram of the operational amplifiers you have studied in these sessions. In the next sessions, the characteristics of the input and the output characteristics of the op amp and the ideal and the practical operational amplifiers, how it works, and we can explained about some definitions of operational amplifiers in this IC. For example, I have already explained about this IC's fabrication methods, monolithic and thick and thin. I have explained that in the fabrications method, in the small chips, many of the transistors are fabricated. The here how that fabrication methods, how that voltage setting for the IC. Yes, ನಾವೀಗ 5 to 18 volts ಅಂತ ಅಷ್ಟೇ ಹೇಳ್ತೀವಿ. Why it is not taking the more voltage? That is also very important. That part, what will you define that sentence? ಆ ವರ್ಡಿಗೆ ಏನಂತಾರೆ? ಆ ವೋಲ್ಟೇಜ್ ಕಂಟ್ರೋಲ್ ಮಾಡೋದಕ್ಕೆ how it can fabricate it. It can be explained all those things in the further classes. Okay, thank you so much for watching this video.